in order to work out the range in part I, you do need to know what the graphs look like. So I'm going to do a quick sketch of the first one. The way I look at modulus graphs is by thinking step by step. So the first thing I'm going to draw is y equals 2x, straight line graph through the origin. Now if I had 2x plus a, I've got to imagine that I've shifted the graph up by a. So I'd have a here on the y-axis, and then when you make y equals 0, you've got minus a over 2 on the x-axis. Okay, if I now draw y equals mod 2x plus a, what those mod signs mean is that anything in the negative side of the graph I have to reflect upwards. So you get this V-shaped graph. Like that. Okay. And then finally you've got this plus 3a bit here, which must mean that you've shifted the whole graph up by 3a. So imagine that you've just moved that a would go up to 4a now. And the lowest point would be 3a because it was originally at 0. Okay, so that's what the final graph looks like for fx. Now, what they want to know is the range. So what they want to know is the possible y values that exist for this graph. And you can see that you don't have any y values below 3a, only at 3a and above. So I can say that the range of fx is anything above and including y equals 3a. Okay, so that's the first graph. The second one is a lot simpler. It's just a straightforward linear one because a is just a constant. So what does that graph look like? The graph of g will just be a straight line graph y equals 5x, so quite a steep gradient, and the whole thing's been moved down by 4a. So it would be steeper than the other one that I drew. It would cut over here at minus 4a, and it would cut on the x-axis when y equals 0, so that gives you 4a over 5. Right, so that is 5x minus 4a. What's the range for this graph? So what are the possible y values for this graph? Because it's just a straight line graph extending up to infinity and down to minus infinity, then I can just say that y is all the possible real values. So the range for gx is y in the set of all real values. Okay, so that's just part I answered. Part 2I says, why does f have no inverse? Well, if you look at the graph of fx, it doesn't have one x value mapping onto one y value. Only at this lowest point here, nowhere else. So for example, if I pick y value up here above 4a, let's say here, and extend it, you can see that there are two possible x values with that one y value, and that is what we call a many-to-one function. So you will see parabolas, for example. You pick a y value and you'll get two x values that map to it. So we know that inverses only exist for one-to-one functions. So what you can say is f has no inverse because it is many-to-one, or you can say it is not a one-to-one function. However, gx is a one-to-one function because it's just a straightforward linear graph. We need to work out the inverse for it now. And the method that I always use is to write down y equals, and then I swap the x and the y, and then just rearrange to make y the subject. Okay, so that means that y, or the inverse of g, is x plus 4a over 5. Okay, the last part. Solve for x the equation g f x equals 31a. G f x is a composite function, and what we've done is we've put the function we've put the function f into the function g. So what that means is wherever there's x in the g function, we replace it with the f one. So if this is gx, instead of writing an x over here, I'm going to write the whole of my g function instead. So I'm going to have 5, and then a big bracket, 2x plus a in the mod signs, plus 3a, minus 4a. Okay, so this we have to obviously simplify. So I'll have 5 mod 2x plus a, and then the 5 multiplied by the 3a would give you 15a, and then you take the 4a away and you're left with 11a. Right, so that equation equals 31a. So let's see what we can do here. We need to make x the subject. Easiest thing to do is to move the 11a over to the other side. And then it looks like we can divide everything by 5. So we have 2x plus a in the mod signs equals 4a. Now, when you're solving mod equations, it is good to see what the graph of each looks like and to see how many points of intersection there are. So if I drew mod 2x plus a, it would look like this. It would cut through a there and minus over 2 there. And if I drew 4a, which I'll do in a different color, let's see, that's 4a there. You can see that there are 2 points of intersection, one in the positive part of the mod graph and one in the negative part. So let's find those two. We're going to have to look at the positive part equal to 4a and the negative equivalent equal to 4a to get the other solution. Okay, so you just solve those like you would normal equations, and you get x is 3a over 2, and on this side you've got minus 2x is 5a, so you've got x equals minus 5a over 2, and that makes sense. You're expecting to get one negative x solution and one positive one.